Good morning, guys, or good afternoon, whenever you're looking at this. Today we're going to start Chapter 10, and I just want to give you a little intro as to what we're going to be talking about in Chapter 10. So first off, the very first page of your notes, you're going to see these pictures at the very bottom. These are called conic sections. So if you'll notice here in the picture, you've got two cones, and then you've got a plane, so like a two-dimensional plane that is slicing through the cone. Okay, and there's four different ways that this can happen that we're going to talk about. First, if it slices through kind of an angle, it hits the side of the cone and comes out the bottom of the cone, it creates this shape right here. Well, that's a parabola, okay, which you've talked about in like algebra courses. When you solve a quadratic, the graph is a parabola. We're going to talk about a parabola in a slightly different way, okay? If you take a cone and you slice it parallel to the base, then it's gonna pop this little, top off, and you're gonna have a perfect circle right there. So circle is one of our conic sections. If you slice at an angle, well, it's gonna take that circle and it's gonna elongate it in one direction. So that's what's going on here. This is called an ellipse, where it comes in, hits one side, but it comes out not parallel to the base, and so that kind of takes our circle and kind of changes the shape a little bit. Okay? And then lastly, we're going to talk about something called a hyperbola, which involves both of these cones. You come in, you hit the base of one, and it comes out the other side, so it's going to create something that looks like a parabola. This is not a parabola. Okay? And then it hits the other side and comes out the base, and it creates kind of a mirror image over here. Again, these are not parabolas. This is one shape called a hyperbola, and we're going to talk about that in more detail in a couple weeks. Okay? At the bottom, you're going to see the equations for these shapes. So there are two equations for a parabola, one if it goes up and down, one if it goes side to side. This is a circle. A circle is a circle. There's only one formula for that. There's only one formula for an ellipse. We'll talk about what could make an ellipse look different. And then there are two equations for a hyperbola. Again, like a parabola, a hyperbola could go up and down, like this one is, or it could go side to side, and so there's a different formula for that. Yes, you will have all these formulas. You'll have this little formula sheet when we take tests and things over these, okay? But we're going to talk about them one at a time. Now, if you turn your page, you're going to see this. This is a review that I need to do before we get into any of these conic shapes. If you looked at these formulas, they all involve some perfect squares here. This x minus h squared, x minus h squared, y minus k squared. There's all these little perfect squares. Well, we need to review something from algebra before we get into this, and it's called completing the square. When you're in algebra and you first start learning how to solve like a quadratic equation, okay, there is one situation that is the absolute easiest to solve when you're solving quadratic equations, and that's one side is a square, and then you have something else on the other side, and so all you have to do is take the square root of both sides, and then you're done. So like this problem right here, x squared equals 5, x equals positive and negative, whatever the square root of 5 is. You're done. That's your answer. A problem like this, where again, you have a perfect square over here. So it's x minus 2 squared. So if I take the square root of both sides, it will cancel that square. Now, I will have plus or minus 4, because when you take the square root of 16, there are two square roots. And then I will add 2 to both of those. So I'm going to add 2 to 4, but I'm also going to add 2 to negative 4, and you get two solutions. Okay? This problem here. Now, this, normally when you solve a quadratic, you're like, oh, let's move everything to one side and set it equal to 0. This is a perfect square, though. This factors of 4 that add up to 4 would be 2 and 2. So this is x plus 2 squared equals 7. And now I can use this trick where I just take the square root of both sides, plus or minus square root of 7, and then I can move this 2 to the other side, and you get an answer that looks like we kind of use maybe the quadratic formula. It'd be negative 2 plus or minus the square root of 7, and that's it. That's your answer. Okay, so you did that in Algebra 1, you probably did a little bit more of that in Algebra 2. Unfortunately, we aren't always given quadratics that are in this form where you have this nice perfect square. But we can always create a perfect square. Okay, always. Completing the square always works. It's not always pretty, but it does always work. So, completing the square is a method that can adjust the left side of the quadratic to create a perfect square. So, given the first two terms of a quadratic, so you've got x squared plus bx, and then what is the magic number that will create a perfect square? Always. So first off, notice that we have a 1x squared. We can't have a number in front of the x squared. And then we've got some number here, bx. This magic number will always be half of b. So we're going to take this number, our middle term, we're going to divide it by 2, we're going to cut it in half, and then we're going to square it. Always. That always works. If I have x squared plus 4, and then I want to know what this is, cut this number in half, think of this as a positive 4, cut this number in half, that'll give you 2, square that number, 2 squared is 4. That is now a factorable quadratic that will factor into a perfect square. Factors of 4 that add up to 4 are 2 and 2. So this is x plus 2 squared. That is now a perfect square. Okay, look at this one. X squared plus 12x, what's the magic number? Well, half of this, so 6, and then squared would be 36. And that factors. It factors into what? X, well, remember when we took half of that and we got 6? That's the number that always goes in here because we squared the 6. And when you do this next step, you need factors of 36 that add up to 12. Well, it's going to be 6 and 6. So it's x plus 6 times x plus 6, which is x plus 6 squared. Okay, look at the next one. X squared minus 6. So again, half of that would be negative 3. Negative 3. When you square negative 3, you're going to get a plus 9. And the factors of 9 that add up to negative 6 would be minus 3 and minus 3. So x minus 3 squared. This last one, now this is not something that I don't think you're going to see anything like this. You would have seen this in algebra, and this is why we don't always like this method. But what is half of negative 3? Well, it's negative 3 halves. And then what is negative 3 halves squared? Well, negative 3 halves times negative 3 halves would be positive 9/4, and that's what our quadratic looks like. Okay, so sometimes it's kind of a pain in the butt. But again, this would factor into x, and then remember, when I took half of this, negative 3 halves, that's the number that goes into my parentheses. That's the factored form. Okay, and this works because then if I'm solving a quadratic, so let's say I have this, there are no factors of 6 that add up to 8. This is not factorable. If I get rid of this 6, I don't like this 6, that number does not work for me. So if I get rid of it, I'm going to put a little blank here. I'm going to move it to the other side. That'd now be a negative 6. But I'm also going to put a little blank over here. Remember, whatever you do when you're solving an equation, if you do something on one side, you got to do it to the other side. Okay? And this is going to be super, super important for Chapter 10. Okay? In fact, you cannot pass this test that we're going to have if you cannot complete the square. So make sure you're paying attention to this. Okay, if I want to turn this into a perfect square, I'm going to take half of 8, so that's 4, and then I'm going to square it. So that's going to be 16. Now, you've upset your balance. So if you're going to add 16 here, you got to add 16 over here. But now this is a perfect square. This is x plus 4 squared. This side is negative 6 plus 16, that's 10. But now I can solve it by just taking the square root of both sides, plus or minus radical 10. And then I can move the 4 over, x equals negative 4 plus or minus radical 10. And those are my two solutions. Whatever negative 4 plus radical 10 is, and negative 4 minus radical 10, those are my two answers. But that's the exact form without like rounding any decimals or anything. So that's perfect. Okay, look at the next one. Again, x squared plus 6x, this is not helping us. Okay, factors of negative 18 that add up to 6. It doesn't work. Like, you got negative 9 and 2, but that would add up to negative 7. That's not what we're going for, or positive 7 if I would have switched the numbers. But I need a 6. Okay, so let's get rid of that number. That number is not the number we want. We want the number that'll create a perfect square. So we're going to move the minus 18 over here. I'm also going to put a blank. You will always see me do that. Whenever I put a blank on this side, I'm going to put a blank on that side just to make sure that I balance things. So again, what's the number that goes in here? You should know this. It's going to be a 9. But then I'm going to put a 9 over here. Okay, now I've completed the square. This is super, super important. This is now x plus 3 squared. 18 and 9 is 27. Now I can take the square root of both sides. X plus 3 equals the positive and negative square root of 27. And then I can move the negative 3 over. Technically, this can simplify. 27 is 9 times 3, and 9 is a perfect square. So you could simplify this. So I'm going to go ahead and do that. So what's that? 3 radical 3. And that would be the correct solution using completing the square. Okay, so again, this is going to be super important. So if you got lost anywhere, I would back up the video to where I talk about it here because you're going to have to know how to do this. Okay, thanks.